Yeah, so hello everyone. Yeah, welcome to another lecture series on um in core mathematics. And in this session, we'll be looking at indices and logarithms. So we'll start with indices first, then we talk about logarithm. Okay. Now, indices is coming from the word index. Index. So index is singular, then indices is what? Plural. Now, what is it? So when you have series of numbers multiplied, series of similar numbers multiplied against one another. Example, 3 times 3 times 3 times 3. Indices is the simplest way of representing these, right? So when you have a series of numbers being multiplied against one another like this, indices is the simplest way of writing this, okay? And it makes it brief. And what's the best word to use? Um, yeah, it makes it brief, or let me say cumbersome. So this can be rewritten as 3 to the index of 4. So this 3 by 3 by 3 by 3 can be rewritten as 3 index what? 4. And this is what indices is about. So it's a simple way of putting up numbers, all right? That's it's representing these numbers in a more compact form. Yeah. Another example. So you can have 4 times 4 times 4 times 4 times 4. Yeah. So you can see one number multiplied against itself many times. Now, how do we write or put this in a simple or compact form? So we can represent this as 4 index. Now, the power is gotten from the number of occurrences. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4. So 4 index what? 5. So this is what indices is about. It's important you get to the basis, the foundation, and then now we can delve deeper. So, so the the number on top is what we call what? Index. Okay. So right here, 3 to the power of 4. 4 is what we call the index. And the one underneath, or how do we put that? For the lack of better word, subscript, okay, is what we call base. Right here, 4 is what? The base. Right here, 4 is the base. Okay. Now, another example. So we can have, I'm sorry. So we can have negative half times negative half times negative half. Yeah. So you can represent this as what? In indices. Rahel. Rahel, how can you put this as How can you put this in an index form? Did you just join or you've been here for a while?
I've been here for a while.
Okay, so how do we represent this in index form?
Negative half
Mm-hmm.
exponent
Mm-hmm.
3.
Good. So do you notice how do you let me ask this. If someone joins a meeting, I get a sound here. Do you also get a sound?
Yes, sir.
Yes, sir.
I think let me take it off. Let me take it off, okay? So it doesn't disturb you. Okay, perfect. Yeah. Now, do you notice how I wrote it? So I deliberately put that in parenthesis bracket. Okay. Just so the three will cover everybody because it's for all of them. And you will get to appreciate this as we progress. Okay. I normally recommend you writing like this than leaving the brackets off and then you probably write it like this. Negative 1 on 2 on 2 to the power of 3. You see, when you do it like this, it is believed, okay? When you do it like this, it's believed that the 3 is for just the negative 1, which is not the case. From this, you're trying to say negative 1 on 2 is recurring 3 times. So that means it's for the whole thing, not 1. Okay, this is just the introductory fee. So, do you understand this? So,
Yes, sir.
okay. I want you all to pay attention because if at university level, almost 90% of the programs you'll be doing come in almost 90. The noises honestly distract me, please. 90% of the courses or the programs you'll be doing um require foundation in mathematics. Okay, so it's important you pay rapt attention. So that is it. So now, considering this negative 1 over 2 eh, to the index of 3, which one is the base and which one is the index? What is the base here? Anyone can try. Hurry and let's go on. Joanna, which
Please,
one
can
is
you
it?
come again?
I'm saying, so now, following the representation of negative 1 over 2 times that, times thrice of that, I mean, following the new representation, which one is the base and which one is the power, the exponent?
Sir, please. I think the negative 1 over the one in the bracket is the base, and then the 3 is the
You're
power.
right. You're right. So negative 1 over 2 is the base, and 3 is what? The index. All right. Now, another name given, I believe you all have a note and you're making some, you jotting something down. Another name for the index is what? Many of you should be familiar with that. It's what?
Exponent.
Exponent or power. So if you find us using this, it's just the same thing. Okay, so we are done. Now, I don't think any of you should have a problem with writing numbers with their index. Let me see. Let me see the participants. I just want to be sure everyone is fine. Uh, who is 1 second? Now, now, any number written in an index form obey certain rules. So all num and if you observe, you see that with the problems we've been dealing for a while now in mathematics, you meet numbers in their index form, okay? And you meet numbers many a times written in index form, and they obey certain rules when it comes to addition, subtraction, and stuff like that. Okay. And it's something I want us to be looking at. Now, so let's look at the laws of indices. Laws of indices. Yeah, laws of indices. Um, all right. So there are three, no, yeah, I was right. So there are three laws we'll be looking at. So one of them is the addition law. Yeah, so one of them is the addition law. So let's look at what it is. So law one. So now it says that if you have a term, okay, with an exponent, multiplying the same term, take note of my words, with an exponent. So I said when you have a term with an exponent, multiplying the same term with an exponent. I did not say with the same index. I did not limit myself. Hmm? Where I threw emphasis on is same terms at the base, right? The exponent could be the same or different. It doesn't matter. So when you have a term multiplying the same term, okay, now what happens is that you pick one term because they are the same, then since they are multiplying, you add the powers. So the powers is going to be m plus n. And we can put this into practice. So example, many of you are used to this, so I'll rush you on a bit. So example, you may have 5 to a power of 2 multiplying 5 to a power of 4. So since the bases are the same, what happens? Anybody to try? The bases are the same,
Sir,
they are multiplying. Go on.
sir. So it will be 5 raised the power 2 plus 4.
Yeah, so 5 to the power 2 plus 4. And if it can be simplified, you do so. Joanna, what would that be? Joanna, what would that be? It's been a while I have a conversation with many of you, so I find it hard to identify the personality behind the names. Yeah, Joanna, what would that be? Safia, what would that be? Yeah, so 5 index 2 plus 4 is 5 index 6. Yeah, it's 6. When you add 2 to 4, it's 6. Right. So there are some illustrative examples. I will do one and you do the rest. Now, the first one, you have to simplify 2 index 3 times 2 index 2. The next one, you have to simplify 5 index 1 times 5 index 2. The next one, you have to simplify x index 2 times x index 3. The next one is Madam Abigail with us.
Yes, please.
That's right. The next one, you have to simplify 2 exponent 2x exponent 4, y exponent negative 3, 4x exponent negative 2, y. Okay. All right. Let's look at this together. There are a few things I want to see before you even begin. There are a few things I want to see. Number one is when you have a number standing on its own, example 5, it means the power. When you have a number standing on its own, example 5, it means, just give me some seconds. Yeah. Yeah, the power running through my cable is greater than what the laptop can take, so it's reacting to itself. I'm coming. So when you have a number standing on its own, example 5, it's believed the index is 1. So if you have a number standing without an index, meaning the index is 1, it could be a symbol, a letter, for example, E. So if it doesn't have a power, take the power to be 1. Another thing, when you see two numbers joined together, it could be numbers or variables. When you see two things joined together and there is no operation sign in between it, what do I mean by operation sign, operational sign? When you have two things joined together and there is no operational sign in between, what do I mean by operational sign?
Sir,
Yeah.
means they are not compatible.
No, that's not what I'm looking for. Anyone else to
Please, is
try?
it the either addition, subtraction, or
Exactly. Yeah,
multiplication?
that's what I wanted to talk. I wanted you to bring on. So when you have two things joined together, I'm being careful with my words. I don't want to see two numbers and then you see letters and you think it's out. So when you have two, for the lack of better word, things joined together, okay, and there is no addition in between, subtraction or multiplication or division. There is no operational sign in between. Those two things are actually multiplying. Did you get that? They are multiplying. I just don't want to reference you, but just so an example is this. So assuming you have and usually it's a number and a letter. We do that often with numbers and letters. So for example, I give you 3M. Okay, you see there is nothing in between. There is nothing, there is no operational sign like a plus or minus or multiplication or division in between, right? So if you see two things joined together without an operational sign, it's actually multiplying. So 3M is the same as what? 3 times M. Okay. So I've said two things. When you have a number standing on its own, the power is
1.
1. The second thing I said, when you have two things joined together without an operational sign in between, the sign or what's happening to them?
They are multiplying.
They are
They're
multiplying.
multiplying. Thank you. Then one last thing. If you also see bracket, okay, bracket separating one thing from another, that thing is multiplying the other. Okay, when you have brackets differentiating two things, that bracket there indicate that this is multiplying that. I'm done. Now I need you to try this and send a shot. Do it, send a shot and send it to me on WhatsApp. I'm waiting. I'm gonna pause it for now. And by the way, if all right, so let's look at this together. Yeah, so we have so for 2 to the power of 3 times 2 to the power of 2. Yes, anybody to help us? Anyone to help us?
Times. Then we have 2 exponent 5.
Yeah, I would prefer you give it to us in stages.
Okay, so it's so
Mm-hmm.
please correct me if I'm not using the right
That's
terms.
okay.
Okay,
That's
so
okay.
thank you. So it's 2. I did the 2 exponent 3 plus 2
Okay, good.
equal to 2 exponent 5.
Which in turn will be 2 exponent 5. Yeah, sounds great.
Yes.
Let's look at the next one. The next one is 5 index 1 times 5 index 2. Yes, what do we have?
So
Mm-hmm.
with that one, you get 5 exponents 1 plus 2,
Okay. Which is
which will give you 5 exponents 3.
okay. Is there anyone on here who is having troubles understanding this? You can simply leave a test. The next one, x exponent 2 times x exponent 3. Yes, anyone? So here the number is changed to a letter. So what happens? It's the same approach. Mm-hmm.
So it's same approach. So x exponent 2 plus 3, which is equal to x exponent 5.
Yeah. Now let's look at the last one. The last one. That's Ivy. Jessica, if the time is up, notify me. So
Yes, sir.
yeah. So Ivy, we have 2x exponent 4, y exponent negative 3, 4x exponent negative 6, oh, negative 2. Yeah. So let's see. Yeah, so here numbers should deal with numbers. I already told you the brackets indicate that they are multiplying. Okay, you can picture it this way. 2 times. You can picture it this way. I said that 2 joined to x means it's 2 times, so it's x exponent 4. Yeah. Okay. X exponent 4 is also joined to y exponent 3. So meaning they are multiplying. Bracket is there, meaning they are multiplying, right? 4 is joined to x exponent negative 2, meaning they are multiplying. Okay. Then times y exponent 6. I want to slow down and find out if you good. Is that okay?
Yes, please.
Yes.
Let me go send something. Let me see. I think you can mark you're on track. You can mark it with what we're seeing. So if this is it, numbers should multiply numbers. So we're gonna have 2 times 4, which is
6. 8.
8.
2 for 8. Yeah. It caught many of you off guard. How were you thinking 2 by 4 is 6? I understand it's been a
I
while.
wrote 6.
Yeah. Yeah, I know it's been a while. It's been a while you join numbers together. It's fine. Yeah, so it's 8. Now x exponent 4 multiplies x. Oh, by the way, if you're wondering where say it's looking at, I'm looking at this. Okay. Now you see the x, they are the same. So deal with them and they are multiplying. So deal with them. So you end up having x. So that'll be x exponent what? So 8x, just join it. if you want to bring multiplication in between, it's up to you. So 8x what? Exponent 4 plus what? Minus 2. Then the y2 is there. Join it. Y. You can bring times. It's up to you. Y. So minus 3 what? Plus what? 6. I want to stop, and if you have any question, you ask. Does anybody have a question about this? No? The silence means you're fine. So you have 8 index 4 plus minus 2. Please use your calculator. Just punch 4 plus minus 2. What are you getting?
2.
Then y minus 3 plus 6. What are you getting?
3.
3. Don't stress your hair so much. Please use the calculator. And that is it. There's a simplification. There's a simplification. Right. Now, let's look at law 2. So, Abby and those I couldn't give a remarks about your work, please mark with what you just see. Juliana, I see one Juliana here, or it's not. No, Joanna. I hope you are following. Law 2 or second law. So this one, it says when you have a term with a power, dividing, okay, dividing a term, I mean the same term. When you have a term with a power, dividing the same term with a power. It says since the b's are the same, take one and subtract the powers. So this is the law 2. Let me know if you have any question about this.
Sir, please, can you go over?
Yeah, the second law or everything.
Yeah. Yes, please, the second one.
Yeah, so I'm trying to say that when you have a term with a power, dividing the same term with a power, the power can be the same or different. The emphasis is on the b's. A term dividing same term. Because it's one term, pick one of them and then subtract the powers. And we will illustrate this with an example. Yeah. Yeah, we will illustrate this with an example. Yeah, so by the way, the first law is called product law, not addition law, because we're multiplying the first law. Okay, it's called the product law, not addition law. Yeah, so example. Yeah, so assuming I give you 2 to an index of 4, dividing 2 to an index of 2. So something like this. You see, the b's are the same, right? And that's what matters. So you just pick one. Then we said if it's dividing, you subtract the power. So you have 2 index 4 minus what? 2.
2.
And that will give you 2 index what? 2.
2.
Yeah. Did everyone get that? Did everyone get that?
Yes, sir.
Yeah. So what's your take? What's your answer for this? I don't need the final answer. I need it in steps. So 3, yeah. by the way, do you see everything we're doing clearly on your mobile phones?
Yes, sir.
Okay. Yeah, so yes, what's your answer to this?
So
Mm-hmm.
it will be
No,
3
wait,
raised the
wait,
power.
no, hold on. Jessica, I want someone else to take this. Yeah, okay. I wanna
So 3 raised to the power 3, 3 exponent 3.
1 second. Three, okay, 3 exponents.
3.
Yeah. Oh my goodness. 1 second. Yeah, yeah. No, give it to me in steps.
Okay. So 3 raised to the power 6 minus 3,
Yeah,
and so it will be equal to 3 exponents 3.
that's
Final
it.
answer.
Yeah, thank you. And hey, I was going to tell you guys that when you are you done writing, settle first. I have are you guys there? Can I move on?
Yes, sir.
Yeah.
Yes, please.
I was going to tell you guys that this a to the power of m divided by a to the power of n can be rewritten as this, and it's right. A to the power of m over or on a to the power of n. So if you find something on something, it's the same as the division symbol, okay? That bar means division. So if you see this, what should matter to you is what? The base. Hmm? What should matter to you is the base. So as long as the base is, what is the base here? Patience, Alma, what is the base here? I have seen that you're on a meeting. What is the base here? Um, I saw someone. Safia, what's the base here? Michael, what's the base? What's going on? Joseph, what's the base? Well, anyone should try.
Sir, please, it's A.
It's
Yeah,
A.
so yeah, it's E. So as long as the bases are the same, um, this and this bar indicate they are dividing. Just pick one, then you see m, you subtract the power, so m minus n. Okay, so now I want you to check this out for me.
Fair.
Yeah, so x,
Well, fair.
yes, please go on
Um,
with your session.
please, what is the name of the second law? You didn't give us.
Yeah, so let me write them for you.
Okay.
So the second law is called quotient law. It's important you know these. I mean, you can't be good in math and lack certain words, math terminology. So you should. Yeah, quotient is because of it's coming from the division symbol. Okay, so quotient law, and then the first law we just said it's called the product law because they multiplying. Product law. Okay. Now back to the question I was making. So how do you simplify x to the power of 5 on x to the power of 2? Victoria, she never got to join this meeting. Where is she? Is Vic here? She or not? Okay. Yes.
Yeah.
Mm-hmm.
So,
No, wait. Jessica, wait. Set, you should try this. Jesse, I'm coming, okay. I just want everybody to indulge in the activity. Yes, set. Let me see. I think,
Sir,
yeah. What are you?
so
Mm-hmm.
so it will be x raised 5 minus 2.
Perfect. Raise to the power of 5 minus. Yeah. I hope you're not texting someone for a solution.
No, sir, I'm on the paper.
Excellent, excellent. So in the end, what are we getting?
You will get x 3.
Perfect. Index 3. Use our words. Index
All right,
3,
sure.
exponent 3, or power 3. All right. You did a great job.
Thanks.
We are done. Let's look at the third law. That's the last law. So now you know how to represent numbers in index form, and you know the laws associated to it. When you see them multiplying, you know what to do. When you see them dividing, you know what to do. I'm going to teach you the last law, then I'll teach you some properties. Yeah, there's some numbers that are behaving some way, some indices that exhibit a certain kind of feature, and I want to show you what your conclusion should be should you find them. Is that okay? Yeah. So let's look at the third law. Since last year, I've been seeing out in this called and never get the time. I'm coming. Okay. Yeah, so the third law. Yeah, set. I've seen your work. I'll look at that. Yeah, the third law. Yeah, so now pay attention. Now, when you have a number with an index, okay, raised to an index, that is it. When you have a number with an index raised to an index, the indices multiplies themselves. So you have a to the power of m times n, all right? And m times n is mn. Okay? The powers multiply themselves. And m times n is mn. So if it is numbers, you just conclude. If it's letters, you join them. So if it was m was a number, let's say 4, n was a number 2, it would be 4 times 2, which is 8. Don't go and write 4, 2. That is 42. All right, multiply them. If they tend to be letters, join them. So if let's say it was a to the power xy, x times y, join them, xy. Well, I'm going to give you an example in case you're still not okay. Right. So, all right. So we have 2 to the power of 4, right? To an index of 5. So have you seen it? A number with an index, in parentheses, another index. How do you solve this? Yes, how would you solve that? Okay, anyone at all can try. I'm not going to restrict anyone.
You multiply the 2 indices.
Yeah.
Say that again.
You multiply the two indices, which is 4 times 5.
Oh yeah, the two indices. Okay. I didn't catch that. Okay, so that's going to be 2 exponents what?
4
20.
times 5.
Perfect. Which is someone said the concluding result. What's that? 2 to the index of what?
20.
Excellent. Let's look at the next. I also have this for you. What is the result? Well, this I'll call someone. Safia, I'm still chasing you. I want to find out if your tab you can hear us. What's the result for that? And who is your Zoom user? Yes, what's the result? I think anyone should pick it up. Yes.
3 exponent 2 times 3,
Okay.
which is equal to 3 exponent 6.
Yeah, you're right. Yeah. Now, guys, these are for you. You do it and you send me a picture of that. I expect solution from all of you. Andrews, are you here? Okay, so we have x exponent 2 to an index of 4. We have a squared b cubed to an index of 2. Then the last, we have 2x exponent 4, y exponent 3 to an exponent of negative 2. Kindly write this somewhere. The third law is also called the index law. Okay, so I'll pause and wait for your responses. Yeah, I've received a number of solutions. Let's try it together. Now, those that are not participating, sending your solution, it's not good for you. It's not a good habit at all. So make sure you get your solution to me. Math is not studied by just reading, observing. You have to put it in practice to identify your flaws. Hmm? Okay, let's look at the first one. Solution. So number 1. So the question is x index 2 with an index of 4, right?
Yes, sir.
So now let's go on. So what do we have? X. I said the
X,
power multiplies each power inside, right? So go on.
yes, 2 times 4,
Which is,
8.
yeah, x index 8.
8.
Good. The second one. The question is, yeah, the question is A index 2,
Let's
B
do
index 3, yeah. My machine is
raise the
ready.
power to
Yeah.
8.
Yeah. What is that? What is that? Are you guys
A,
there? Mm-hmm.
A, B,
A, B, no. So the power deals with the power of A2. So this 2 deals with the the index of E. Then that same 2 deals with the index of B.
Okay. Yes, sir.
Now, take note of this knowledge. You use it for the last one. All right.
Yes, sir.
Yeah. So in the end, what are you getting? A to the index of what?
2 times. 8 to the
4.
index of 4.
4.
Yeah. Mm-hmm.
Yeah. And B to the
B
index
to the
of
index of
6.
6.
Exactly. Now, take your time without being one-sided. Use this idea to deal with the last one. So let's see. So you have 2x index 4, y index 3, right? Exponent negative 2. What's that?
Yes, 4. 5, 3.
So
Minus.
the negative, what's the rule? The negative 2, the power outside the bracket affect each single power within, isn't it?
Yes, sir.
So let's begin. So 2, I told you any
Yes.
number standing on its own has a power of what? But many of you forgot that. Any number standing on its own has a power of what?
1.
1. When they are joined together and there is no operation in between, it means they are multiplying. I said all of that. So 2 has a power of 1. So that 1 will be multiplied by what? The index outside. Yeah.
Oh, okay.
Yeah. Then now let's go to the x. You can bring the x there. You can choose to bring times or avoid it. In many cases, we like to avoid it. So the x2 has an index of what? 4.
4.
Then the power is what?
Y.
Oh, yeah, it's multiplying, right? Yeah, the bracket was right, okay, but I mean let's follow you. So times or negative 2. Then let's come to the y. The y2 has a power of what? 3. So it's multiplying to what? The power outside, which is what? Minus.
Negative 2.
Yeah. Then now you simplify where necessary. So that'll be 2 index what? 1 times minus 2. Don't stress your head. Just you see, just put it on the calculator. Yeah, what is that?
Negative 2.
Negative 2 x.
Yes.
4 times the negative 2. What is that?
Negative 8.
Yeah. Then y. Yeah, 3 times the negative 2 is what?
Negative 6.
Hey, you are come to learn a certain property, okay, in the next few minutes. Take note of this. Take
Okay.
note of this. This one. I'm trying to circle some. Take note of this. I'll let you come back again and you can rewrite it in a different style. Listen, take note of that. Okay? 2 exponent negative 2. Take note of that. We'll come to that and you rewrite it in a different style. But if you leave it here, it's okay. I'm going to allow you to think through, and if you have any questions, you can ask.
Y3. Y3. Y3.
Yeah. I'm just waiting for you all to settle. Let me know if you have.
S. 6. Negative. I'm a negative 2.
Are you ready?
8.
So law 1 is called what?
6.
Product law.
Product law. Law 2 is called what?
Quotient law.
Quotient
Quotient.
law. And law 3 is called what?
Index law.
Excellent. Excellent. I'm just asking these questions so we can allow our friends to catch up with us. Set, let me know when you're all set.
So I'm set.
Okay. Why do I have a line running through my work? Oh, I think someone drew this line on our work. I'm sure. Let me see if cleaning will work. It's not working. Oh, Patience, are you on a meeting? Because I just did the last one.
Please, I think it's me. I don't know what happened.
Yeah, it's okay. If you can clean it for us, we'll be glad. If you can't, don't stress.
Okay, I think I can see where.
Yeah, thank you. Yeah, it just went off. I just did that. Are you on the meeting? Right. So now let's see. Give me a moment. I'm responding to Patience. All right. So now let's continue. I was gonna say something. Now, I need your opinion on this. What will be the simplification for this? Well, it's coming from the other laws you've learned. Um, um, so what will be the resolution to this?
So,
Mm-hmm.
X, Y, raise the power 7.
No,
The exponent for y exponent 3.
perfect. So why? It's the same thing. Someone can even choose to rewrite the same question back to us. X4 times y exponent 3. But or you can choose to ignore the sign. The point we're trying to say is that it's not plausible. The answer is the question. Why? My dear, I just told you that you can only apply law 1, that's the product law, when the bases are the same. You can only add the powers when the bases are the same. Now, why are you trying to add the powers when the bases are different? Have you seen where the problem is? So this was just by the way. I just want to let you know you have to listen to every single word I'm telling you, because that's going to be your secret to being able to address many problems easily. Is that okay? I caught you off guard and it's fine. I mean, can I move on? Are we all okay with this? What just happened? Hello?
Yes, sir.
Okay. Now, yeah, so now I'm going to give you some tips, right? We're done with the laws. I'm going to give you some tips. We don't just use laws to solving indices, okay? We use that together with some properties, yeah. So, oh yeah, some properties or rules. So you can jot to this, you can just write order. I'm coming. Order, 1 second. You can write order important rules to note. Don't worry, we have 30 minutes left. So now one rule I want to tell you is that when you have, and pay attention, when you have any number, or it no, when you have any term or number, it can be a number, it can be pay attention. This thing is going to be your savior when you have any term or number. So when I say term, it can be letters. Okay. Now, when I say numbers, that means it's bringing itself properly in numerical form. So when you have a term or number raised to an index of 0, okay, no matter what it is 1. The result is 1. It changes to 1. Okay. So if I'm writing Abigail to an index of 0, do you know the answer? It's 1. It's 1. Just that. Is that okay? So in the same vein, if it's a number, 5 index 0 is what?
1.
1. That is it.
1.
Do you have any question about this? Do you have any
No, sir.
question? Yeah. Now, the second thing I want to tell you, that's root 2. It stems from one of the laws you learned, but it's important I bring it on. Yeah, so root 2. So for root 2, should you have a number or term with an index, okay, another term with an index, and all of these tend to have, let me start with this, then these will come right under. Yeah, so again, when you have a term, okay, 2 terms with an index. Yeah, let's start with this first. Yeah, before we go to the second one we're talking about. So when you have 2 terms with an index, okay, what happens is that the index affects each of them. So the A will be affected by the index and the B will be affected by the index. Yeah, that's not rocket science. An example is here. Yeah, an example is here. So if you have 3, okay, 3m, okay, to an index of x. You see that I said the index affect each thing in the bracket. So it gives you what 3 will be affected by the x, then m will be affected by what to the x. That's what I mean. Let me know if you understand.
Yes, please.
Good.
Yes,
Yes, sir.
sir.
Now, this is still applicable when the numbers inside the bracket even house an index. An example, it still works if A has a power and B has a power, and all of that has an index of 1, and it still works. So we don't care. The n will affect A exponent x, the n will affect B exponent what? Y. You get what I mean? Yeah. So an example is here. Let me see if there is an example before I make mine. Yeah, so I can give you 2 2 exponent 2 times 3 exponent 2 or exponent 4. Guys, so what's the simplification? The power affect each thing. So what are you gonna have set? Can you help us?
Sir,
Yes, sir.
so it will be 2 exponent 2 times
Please,
4.
I'm coming. Hold on. I'm trying to just give me some time. 2 exponent what? 2,
2 times 4.
good.
Then
Times
3
is there.
exponent 2.
Yeah. It's numbers. So you see, you can't ignore the times. If it's letters, you could ignore the times, okay? But you see, it's numbers. If you ignore the times, it's gonna look weird. Just look at this. Set, you just
Okay.
go on. Go on. 3 exponent what?
2 times 4.
Yeah, but it looks weird. Times.
So, okay. So,
So you have to bring the times there because at the end of the day, something will happen. So what's the answer, guys? What's the answer?
so
4
Sir,
times 2 is 8.
yeah.
You get
And
it? Then yes, 3
3
what?
times
2 exponents 8
8.
and 3 exponents 8.
Yeah, that's it. The denominators are not the same. Oh. Don't think you've seen 8, 8, so you're gonna add the powers. We deal with the denominators, not numerators. If the numerators are the same, it's not basis of what justification. I hope you get that.
Yes, sir.
Right. Um,
Sir, please explain that side, bro.
I'm saying that don't jump by saying what? I'm just wondering how you're going to carry on. I'm just trying to say the bases are not the same. This is 2, this is 3, they are not the same. Please close your eyes to the numerators. That's not the basis for justification. The basis for justification is the base. The basis must be the same. Do you understand?
Okay.
Yeah. So here the bases are not the same, so avoid it. If you're wondering, say, so something like this, how would we solve? Just take your calculator and punch 2 to the power of 8. It will give you an answer and you write it down. 1 second. If you point 2 to the power of 8, it's 258. So you write 258 times, then you punch 3 to the power of 8 to give you a result. So that one will also be a certain number, right? Then so it will be 258 times another number, let's say 1,000 or whatever. Then that's what gives you the final answer. But we are doing indices, so leaving your answers in index forms, it's okay, all right? Don't break it down to the bare minimum. Is that okay? Did you catch that? Hello? Hello?
Yes, sir.
Okay. Right. Rule number 3. That's the last rule. I think after this, I'll stop and then tell you the schedules for tomorrow and then I'll close you. I don't want to bombard you so much. Rule number 3. Rule number 3. Now pay attention to this. When you have a number raised to a negative index, oh, when you have I'm coming. When you have a number raised to a negative index, when we say negative index, meaning negative then something. So negative n. N represents a variable or a number. Okay. A variable. So for instance, a exponent negative 1, a exponent negative 10, a exponent, I said n represent a number or a letter. So a exponent negative b for bison, a exponent negative b, all of these fall in the category. Now, when you have a number raised to a negative index, it's equal to it's equal to it's equal to the reciprocal of that number. When I say reciprocal of that number, any number standing on its own is believed to be over 1. Okay, when we're looking at it from a fractional perspective, any number standing, I'm not talking about in decimal perspective. When we're looking at it from an in decimal perspective, then you will see any number standing on its own has a power of what? 1. Do you understand? We said that. We said that. That's from in decimal perspective. Now let's look at it from a fractional perspective. Any number standing on its own is believed to be over 1. Hi guys, are you with me? We all know this. Jessica, are you sleeping on us?
No, sir.
Okay,
They are here.
okay, all right. I'm almost done. Okay. Yeah, so any number standing on its own is believed to be over 1. Now, I said when you have any number raised to a negative index, it's equal to the reciprocal of that number raised to the same but positive index. We are going to repeat it. Any number raised to a negative index is equal to the reciprocal of the number raised to the same but positive index. Let's repeat that together. You can do that while you are there. Any number raised to a negative index. Number B, we are raising it to an exponent or index or a negative index. The tree is not coming. All right. It's equal to the reciprocal. Okay. The reciprocal of the number raised to the same but what? Positive index. Is it? Are you getting used to it? Or you want us to repeat one more time? Any number raised to a negative index is equal to the reciprocal of the number raised to the same but positive index. Okay, so this is raised to a negative index. It's equal to the reciprocal of the number. Now, I said when you're looking from a fractional perspective, that number is over 1, right? Reciprocate it, turn it upside down. Who can do that for me?
It will be 1
Yeah.
over 8.
Good. So it's equal to the reciprocal of the number. Now raised to the same but positive index. The index is what? N
N.
already, right? So it's
Yeah.
N. It's actually negative N. So it should be N. It should be
Okay.
N. I said raised to the same index. So raised to the same index, but ignore the negative. That's what I mean. Any number.
Understood.
Yeah. So we are repeating one more time. Any number raised to a negative index is equal to the reciprocal of the number raised to the same but positive index. So that means that if you are seeing 1 over a exponent n, you can rewrite it as what? A exponent negative n. In the same vein, if you see a exponent negative n, you can do it the other way around. Roger that. So look at this. So do you remember when I was saying, oh, come on, why is it zooming? Please, I'm coming. If you recall, just a moment. Oh, come on. There's a charger. Then when I have time, I have to go and get this. This is bringing us to the end of the lesson, so just stick with me. Yeah, so oh, so guys, watch closely. This thing. You see, I circled that to you earlier on. Do you see it? So this, someone can continue the solution with your new knowledge. You can leave it here or you can continue. Who will continue that for us? It's a number raised to a negative index, isn't it? Isn't it?
Yes, sir.
So let's apply the same ideology. We said any number raised to a negative index is equal to what? The reciprocal of the number raised to the same by what? Positive index. So if you're having 2x with a negative 2, how would you rewrite that? Okay, let me bring it right here. So if you have 2 exponent negative 2, how would you rewrite this? It's a number raised to a negative index. How would you rewrite that? 2 in itself, from a fractional perspective, is believed to be over what? Hi guys. It's believed to be over what?
Over 1.
1. So now,
Over 1.
yeah, so now 2x with a negative 2, what will be the simplification if you are applying rule 3? Reciprocate this. What's that? attempting me to write it, but I won't. Yes, I'm waiting for you guys.
It's 1 over 2
1
exponent
over,
2 exponent positive 2.
good. 1 over 2 exponent positive 2. Yeah. Why positive 2, not negative 2? Because we said that if you have a number raised to a negative index, when you reciprocate it, raise it to a positive index, okay? And we are going to use this a lot. We are going to use this a lot. Now, this this is only effective, okay, when a is not equal to 0. I want you to take note of that. As long as a is not what equal, that number is not equal to 0. Okay? As long as that number is not equal to 0. Do you know why?
No, sir.
Yeah, I'm going to show you. When it's 0, look at what is going to happen. When it's 0, that means we're having 0 exponent negative, and let's choose a number 0 exponent negative 2. I said this is only effective when a must not be equal to 0. The number must not be equal to 0. Because if it is 0, well, you know, any number standing on its own is over 1. So you'll be tempted to do 1 over what? 0, right? Exponent whatever. Exponent 2. Guys, in mathematics, any fraction with a denominator of 0, I believe you're recording a lot of things down. In mathematics, any fraction with a denominator of 0 is not plausible. If you punch any number and you divide it by 0 on your calculator, it will give you mass error. It's not plausible. It's undefined. Are you trying that yourself? 1 over 0. I've punched 1 over 0. In case you're able to see, let's see. If you press an equal sign, it says mass error. Yeah. Is anyone trying at home? Do you have a calculator with you? Yeah. Is anyone trying that at home?
Yes, sir.
Yeah. So this is only applicable when the denominator is, when the number involved is not 0. So rule number 3, include that where a is not equal to 0. Establish that where a is not equal to 0. Yeah. I think I'm gonna end here. There is one more I'm supposed to teach you because I want to give you some examples to try at home. But it looks like it's gonna be a lot of information for you. So it's not even one more. I have 2 or 3. So we'll reserve it for our next meeting. I want you to go home. You're already home. I want you to practice these at home. Go through everything I just said over and over again. Trust me, we are going to use this information for our next meeting. And if you miss this, you'll be lost completely. And I do not like that. I'll try and see if I can get you other examples that are associated with what we just did. Okay. At this point, do you have any
Yes,
question?
sir.
Do you have any question?
That
No,
means I want
sir.
to ask a question.
Yeah, go ahead.
You see, with the third law,
Mm-hmm.
you said A is equal to A exponent negative n is 1 over A in brackets exponent n.
You are talking about
So
rule 3, not law 3. Rule 3. Okay,
yes,
yeah,
the
go
rule
on.
3.
Mm-hmm.
So if you write it 1 over an, is it wrong? Like without the bracket, you bring the
It's also
exponent.
okay because at the end of the day, 1 exponent n, 1 at the end of the day, 1, you see, the n affects each thing. 1 exponent n, it's 1. 1 exponent 250,000 is 1. One exponent, whatever you can think of is one. So I think, let me see if I can. Yeah. Yeah, 1x, I'm coming. I'm trying to do something here. Yeah. Yeah, you can do that. Even if the power is negative, 1 exponent negative 253 or whatever is 1. So yeah, I mean, what you're saying, you can do it that way. Yeah, it's fine. Any other question? Any
Thank you,
other
sir.
question? So you see, everything about math is true. It's not false. And we make these deductions from self-findings. So you see, I wanted to jump to a conclusion, but I wanted to test. I tested with my calculator and it's actually true. All right. So none of these things are imbibed information. They are things that are tested to be true. Okay. All right. Now, this session was recorded and I'll upload and then share the link with you. This will be the end.